In this session, we're going to look at working with point clouds in TBC. It's a fairly in-depth topic. There's a lot to cover in it, so we will probably take the full hour. We may go a little bit longer because I will do a bit of a demonstration of the workflow at the end. We're going to cover an introduction to point clouds, so just a basic look at the point clouds in general in this session. We're going to look at importing them into TBC and the different data types we can support, as well as some of the more common instruments from Trimble range that we support directly. We're going to look at the point cloud module in TBC, which is where the most of this work will be done. It's the sort of core component that TBC uses to handle point clouds. It is an additional module on top of the TBC Survey Advanced package, so you will need that as a minimum before you can get the point clouds module in TBC. We're going to look at digitizing the point clouds once it's in TBC using the CAD tools that are available. We're going to look at the different views and selection tools that you can use in TBC, creating surfaces and contours from point cloud data, exporting that out before we'll actually do a run through of the whole process in live. So we'll see how that goes. It's always fun doing a live demo. For those that don't know me, I'm Ross McAtamney. I'm one of the technical consultants at UPG. I worked at Trimble for 11 years before starting at UPG early last year. Just as an introduction here, if you're unfamiliar with TBC, I really recommend going back and looking at our previous videos. We've done a couple in the lead up to this. For beginners, the introduction to TBC video is a good one to start with. And then the creation of an FXL and templates, that's another one that we will be building off because we'll assume that that's already been done in this video, as well as some of the basic CAD tools functionality that is there as well. So if you're unfamiliar, we will be sort of building on the stuff that we've covered previously. So it's worth going back and looking at those afterwards if there are some steps that you would like more information on. Otherwise, feel free to contact me or one of the team directly and we'll help you out. So with regards to point clouds, point cloud data can be brought into TBC from instruments from the field. So an X7, which is the new scanners that we've got available, SX10, as well as TX scanners. With regards to the format to bring this data in, it's generally just copying the data from the controller into the format that will just come straight into TBC. So for the SX10, it's going to be a job file. For the TX scanners, it's going to be one of the Trimble supported point cloud formats, as well as the X7 as well. Another way that we can bring point clouds into TBC is through UAS Master. So this is a direct link for aerial photogrammetry projects. We did do a session on Friday, and we're going to rerun it again this week on UAS Master for more detail, but we will handle that as a point cloud, and the same tools that can be used for terrestrial scanners can be used for aerial projects as well. The other thing that we can do is import data from supported formats. So there's an E57, a points, a LAS, or a LAS. They're the main industry standards, but we also support a whole slew of other options that are available to you. So once the data has come into TBC, it is just a point cloud, and these tools that we're going to discuss in TBC can be handled for that as well. The benefit here is that you don't necessarily need a Trimble scanner to bring the data in, and you don't have to have collected the data yourself to bring the data in and manage the data as point clouds in TBC. The tools in the point cloud tab are used with any point clouds. So once the data comes in, we can turn on and off individual point clouds as well as collective groups of point clouds. So that data and the tools that are available can be used for any point cloud data in TBC. It's pretty much like the rest of the functionality that we've discussed previously, where once data is in, it's categorized against its type, not necessarily how it was collected and what it was used for previously. There's no hard limit to the number of points that can be handled in TBC. Machine specs is what is going to be that limiting factor. We don't say you can have an upper of 250 million points, for example. In TBC, you can use any number of points. The problem will be your machine size. For example, my laptop here can load a point cloud of 3 billion points. I'll show you that later. You can load it in quite quickly and it runs normally. So don't feel that there is a limit to the number of points. The problem will be in terms of the speed of getting data in, which is going to be the time consuming element, as well as running some of these functions that we're going to talk about. That will also be a time consuming element. But in those cases, I recommend just setting it up and we can batch import and batch run these processes and go and get a cup of coffee or leave it running overnight if you have big jobs. And hopefully when you come back to it, the process will have been completed that way. So these are things that, you know, there are things to be aware of in terms of time and machine specs when handling point clouds, but overall TBC is very robust and it can handle large data sets fairly well. The time taken to process and bring in data into TBC is a one-off process as well. So once it's saved in a VCE format, you can load a data set very quickly with a large number of points. And I will show you that at the end, where we'll load that 3 billion point data set from scratch. And that will hopefully show you that it's quite easy to manage data of large sizes once it's come into TBC. The more points in the job, of course, though, the longer processing and functions will take, such as the create region, or even some of the selection tools may become a bit slower. So it is worth looking at splitting up projects into smaller sections if you have a large number of scans, for example, or a large number of points in each of the scans. When we look at importing data into TBC, there are a couple of different types of point clouds that we can have. We have two main functions with regards to point clouds. We have registered and unregistered. So registered is where, when you're doing multiple scans out in the field, each scan has a relationship or knows where it is related to a previous or next scan. So for registered scans with the X7 or the SX10, that data will come straight in from the field already registered. By that, you can see here on the screenshots on the right, they're already tied together. So for an SX10, you have a traverse line that runs through it from all the total station setups, so it has that relationship, whereas the X7 does cloud registration in the field, and so that step is already done once it comes into TBC. Once data is coming into TBC, if it's unregistered, you can do that step yourself. You can geo-reference scans. You can do what we call cloud-to-cloud-based registration or plane-based registration, where TBC will automatically try to determine the relationship and match them up. This is the same functionality that is available in Trimble RealWorks and other major packages. The advantage with using something like an SX10 or an X7 in this case is that you don't have that time, that you don't spend that time trying to tie the scans together when you're processing the data. That data is already coming in, processed and ready to go. In the case of the X7, you can even colorize the scans on the instrument so that when the data comes in, it is already colorized, which will also speed up that process as well. So it is worthwhile looking at, for big jobs particularly, looking at something that will already come in pre-registered so that you can bypass that registration step. But that's not to say you don't need to do it or can't do it yourself. Again, you can tie scans imported from file formats as well as raw data, so there's no real limit there, and the process is quite easy in TBC. When we're looking at point clouds in TBC, the main tab that you will find when you purchase the point clouds module is the point clouds tab itself. Like everything in TBC, we look from left to right. So the left-hand side is looking at data coming into TBC. As you move through the process, you're creating regions. So the left-hand side, you're going to register your scans. We're going to look at georeferencing scans if you want to move your scans from point A to point B. I recommend georeferencing scans rather than shifting a scan using the survey tools. It's the georeferencing the scans will better position the data, and you'll probably be an easier process. However, be aware that some scan types will not be able to be georeferenced. It will need to be done using the other tools available in TBC. There's also creating a scan station, which that will allow you to break out a scan into an individual scan location. So say you've done an SX10 scan and you want to take one of the scans out to move it independently, then that would be creating a scan station from your data, and you can unlink it from the rest of the scan and handle it independently as a scan itself. The next moving along is the regions tools. So this is creating regions, shifting data between regions. The regions in TBC are used to create smaller groupings of your point clouds based on the type of data that it is. So there is a function in TBC that will break down the data into different types, so vegetation, buildings, natural surface, power poles and signs, as well as power lines, and then there's also a default layer where anything that hasn't been able to be identified, or things that generally we would call rubbish, put onto, so that you can turn that off. But it allows you to easily manage the data. So region tools will become quite powerful and quite handy moving forward, and we'll discuss that in more detail later on. Then you've got your view tools. Because you're using 3D data, the view tools are fairly important in TBC. So limit boxes will mean that you can constrain the data to a certain section within your view. You don't need to worry about seeing all the data all the time. The 3D view is also very important because you can rotate around your data and see different aspects of the data. There's also station views, which is fairly good for using scan data, where you can set up on your viewpoint out of where the station setup was and see the data from that location as if you were looking through the instrument, which can be handy at identifying points and things like that. We also have the plane manager, which is extremely useful for point cloud data, for changing the view plane and being able to manage and draw data onto a different plane rather than top down. Or in 3D view, it sort of sets a plane in an area, and you can within that have a cutting plane, so you can specify the thickness of the data through that plane, which will help you to identify data and also trace data coming from that. When you're keep going along, we've got the rendering grouping. The rendering grouping is looking at how we visualize the points. So you can change the color of the points depending on different presets. So we'll look at the different types of presets that there are. You can colorize scans. So colorizing scans is the step of putting true color against the scans if photos were taken out in the field. This is done as an automatic step when you import data into TBC, but you can turn this off. I would recommend turning this process off and running the colorization process later, and I'll run through that a bit later as to why in more detail. However, the biggest benefit of turning off that automatically colorized scans on import function is that the data will come into TBC pretty much straight away. It'll be faster to get the data in, and you can get up and running and processing that data quicker than waiting for that colorization process, which can take a little bit of time. There are also things like being able to expand the size of the points in TBC, so you can better see points sometimes when you can do that in this rendering section, and also the shading options. So you can put some shading options on to try and enhance the view. The last grouping on this point clouds tab is the deliverables section, which looks at different types of deliverables and how you can get some data out of TBC. So scan to CAD will put CAD points on your scan cloud. In TBC, we handle scan points as a particular type. It's not going to be like a CAD point where you can put a text attribute against it. A scan point is held as a scan point, and it's in relation to all the other points of that particular classification. So when you want to do something like put a spot heights through a paddock, for example, if you're using, say, UAV data, or up against a wall, scan to CAD will be what you would use to put CAD points throughout the scan at a certain interval, and that will then be able to be having text attributes and things put against that. The other advantage with scan to CAD is that it will create CAD points which are better off being handled in like AutoCAD or something like that. Just be aware, when we do create points in TBC, we are creating points against a physical point that was measured. It's not going to create or identify a 3D point in space based on where you've clicked. It will try and pick the closest point to where you've selected, so that you are actually creating data against things that you've already measured. We're not assuming or predicting anything at this stage for doing that sort of thing. In the deliverables section, we're also looking at the extract point feature, which I'll run through. It's an automated function to get some point data out of feature groupings in TBC like light poles and trees. There's also the ortho photos and processing panoramas in here to generate that imagery that you might want, as well as the published clarity, which is an option where we can show and visualize data in the cloud, and you can share that data with customers so that they can visualize it through just a web browser. They don't need to download a file format and view it themselves at their end. So there's a lot in this Point Clouds module and tab that is very useful for anyone using scan data or any form of point cloud data. So looking at the start here, if you haven't got a registered point cloud when you bring it in the data, you can do this register scans option. So when you select that, it will list all the scans that are available in TBC. And what it does is it takes a reference scan. So that's going to be a scan that you hold constant. And then you have a moving scan, which is a scan you're going to shift into match up with the reference scan. So the reference scan will always be held at its constant location. There will be no shifting against that. It's the moving scan that is going to be moved to that reference scan. So in the case here on the right, you can see that we've got a reference scan and a moving scan. There are two ways that you can do this. One way is a plane-based registration. So that is where TBC will automatically go through and work out all the locations for all the scans based on the algorithm, and it will match it all up. Now, most of the time this works. However, there are cases where you might want to manually do it, or that TBC hasn't been able to identify enough points of overlap, or it's quite a complex scan that's made it hard to identify points of overlap. So it's better to do, say, a pairwise registration where you pick a point in your moving, in your reference scan, and you pick a point in your moving scan that is in the same location, and it will use those two to identify points that will match up with each other to better manage the joining of those scans. It doesn't have to be exact. You're not looking for exactly the same pixel. You're just looking for the same area in the two scans for it to point to. This process uses up to 3 points that you select. I would recommend trying to use all 3. However, you can do it with just one, and it will work fairly fine. The more points that you use to identify, the better the matching. The other thing that it will tell you in this pairwise registration is the residual error, so how close the system thinks that it's got to matching the two scans against each other, as well as the overlap. So how much overlap there is between the two scans, so that you have confidence that you're in the right place and that it's close. You can run that optimized pair registration step a couple of times. So if in the case here where I've got 3 points selected, you select your 3 points and you optimize the pair registration, it will give you a result, and you can click that optimized pair registration button again against those same points too. Sometimes that will tighten up the network a little bit further. You can run that as many times as you want, but what you will find is that there will become a point where the system won't get any better, and it will start to there can become a point where it starts to shift further away. So it is a bit of a trial and error in this game to try and get that as accurate as possible and as close as possible. In the case of lining things up, it is recommended to identify fairly identifiable features, not just a point on the ground. It's better to pick a particular sign pole and a particular tree, and that's why there's benefit in handling multiple points so that you can really tell the system this is exactly where I want to shift it to. There is an auto align option that allows you to just select one point in each scan in this step, and it will automatically run in that run the process in that function. That can be used quite easily, but if you turn off the auto align function, you will have the ability to use all 3 and then determine yourself when you want to run that matching. So that's what the auto align is doing. By default, it's turned on. So sometimes it's worth turning off the auto align function, selecting your 3 points and then running it, but it's up to you. It's worth having a play with all of this functionality with some data that you've got to just get familiar and sort of understand what each process does as you go through it. As I mentioned before, there's the colorization step. Now this is run by default when importing the data into TBC from, say, an SX10 through a job file or an X7. In the case of the next 7, if the data has already been colorized, you don't need to run this step. The data will come in that way. For the SX10, certainly the colorization process needs to be done in TBC. When you run this colorization step, it does take a little bit of time. So if you, in the properties for TBC, sorry, in the options for TBC, they're in the point clouds, it allows you to turn off this function by default, and you can come back and run this function later. The benefit here is that we can run some of the other things to help improve the imagery, and then run the colorization step against our improved images, and that will help just improve the quality of the colorization of the images. The other thing is that you get the data in quicker into TBC, and you can start working like pretty much as soon as the data comes in, rather than waiting for this step to be taken. It is worth looking at when you're looking at, noting that when you're looking at the sort of scan data, you may not use a lot of colorization in the whole process. When you're digitizing the data, it looks good, it's great for a customer. However, when you're digitizing data, sometimes things can get lost and be obscured, and the way that images are taken in most scanners, the colorization doesn't always help the process of identifying what's going on out in the field. So there are other techniques to show the data, and it will help visualize the data better than colorization. But for most people, it is worth running the colorization step to just see the data in its colorized form. And for customers, certainly it does look better, and it is a bit more meaningful. When we're moving along, and once you've run this, once you've registered the scans and then you've colorized the scans, it's worth looking. The next step would be to classify the regions. When you select the data in terms of the point cloud in TBC, it will select all the points in all the scans essentially in TBC. So it handles it as one single grouping. The classify regions tool will allow you to automatically break up that region in that one single region into multiple regions based on the type of data that it is. Now, this is based on an algorithm, so it will get it about 70% correct. It's worth noting here that 70% correct is just going to break the back on most of the work that you're going to do here. It's not like you have to spend ages doing that last 30%. That last 30% is just going to be tidying up some data, shifting it between layers. It's much easier to have run the function and then get that 70% accuracy done and then tidy up the data than it is to do this from scratch. It really is quite a good function to have in TBC, and there are a lot of tools to make it easy to shift data between regions so you can tidy it up. Now, it's up to you how far you want to tidy up data as well. You may be just looking for a specific element, or you may want a highly tidied region, but the tools are there to allow you to just shift the data around as you see fit and as you would need as you go through this process. So when we're looking at examples like this is an example which we are going to run later. It's a roundabout that was scanned with an SX10. What's happened is we've run the Create Regions tool, and you can see here that there are the regions are blue, which is buildings, green, which is vegetation, brown is the ground or the natural surface, red is the power poles and signs, and yellow is the power lines. And then there is a white layer in there which we call default. The default region is something that we would turn off. Now in TBC, I wouldn't recommend deleting data, and it makes it very hard to delete data. We try and retain the data integrity as much as possible so that you always have a complete data set. Also, you may need to come back to some data that's on a region later on. So it's very hard to re-import a specific section of data. You would have to re-import all the data. It's always worthwhile just putting any data that you are not wanting to worry about onto the default region, and then in the View Filter Manager, you turn that region off visibly so you don't have to worry about it, but in the background it's there if you ever need it. In the case here, you can see what has happened is that they haven't closed off the road for doing this scan. That was the reason why the scanners were used. They didn't want to spend the money or time to close off the road, and also they didn't want to have issues. They wanted to make sure that safety was a concern that they were looking at, so they didn't want people walking through the intersection. So in this case, they used scanners on 4 corners of the intersection. They set it up to scan 4 rotations. The reason for that is if a car passes in front of the scanner in one of the rotations, hopefully that one of the other 3 rotations, there won't be that car there, so they can get data behind it. So what you're left with is sort of this thing that looks like trees in the middle of the road, and as you can see here, the system has determined this as being vegetation. This isn't a big deal though, because in the top left you can see that the green grouping looks like essentially a bush. This is just vehicles that have gone around and been captured in the scan. In the top right, we've turned off all the other scans, all the other regions apart from the high vegetation region. So in the View Filter Manager, once you've done classify regions, you can turn on and off different regions as if they were essentially a layer, which they are. What we can then do is we can select this grouping of cars that has been misclassified, and then change the layer to the default layer, so that down in the bottom right you can see now that those cars are on the default layer. This is a very straightforward and simple process to do, and as you'll see, once you turn that data off, you in the screenshot in the bottom right here, you can see that you can just get to that raw data underneath, and you're not worrying about that affecting your scan in any way. So when it comes to digitizing the data, you're left with a very clean and easy to use model, and that is the purpose of this classify regions tool. And then the more time you spend shifting data between regions and cleaning up the data, the easier it will be to identify where specific data is, and you can just turn it on and off these regions as you see fit. When we are handling regions, another thing that you can do is shift data between regions quite easily. You can create your own regions. So while we have an automatic set of regions, those 5 or essentially 6 with the default region that I've spoken of previously, you can't add a automatic process to say identify cars. These are algorithms, so they would need to be programmed in, but we can allow you to create a new region, and you can manually put data onto a region for cars if that was what you wanted to do. So you can manually create your own regions and shift data onto those regions using the tools available, and that will be quite easy. It just won't be the automated process. In the case of looking at data in TBC, when we're shifting data between regions, there are a couple of tools that are worth noting as well. So we have the ability to select data in TBC. However, in 3D view, if you use the polygon select, it won't, the minute you start selecting data, it won't let you rotate the view. That's because the polygon select tool and the rectangular select tool really are looking at where the 3D view is and what data is selected within that 3D view. We're not sort of selecting 3D points, we're essentially selecting 2D points in that 3D view, and anything towards the camera and away from the camera is going to be selected. So in the case of the power pole on the top left corner here, we've gone around and created a polygon around it in the top right, but you can see behind it some of the vegetation has been included as well. So what we want to do is we want to unselect that vegetation data. So in the point clouds tool, there's a keep in and keep out option. So the keep in option is what we've selected first here. So what that's done is it's hidden all the data that wasn't in that selection set. So what we've done in the top right there is selected that power pole and the bushes behind it, and we've selected keep in, and that has hidden all of the point clouds that weren't selected here. Then from that data, you can then run that keep in, keep out tool again. So in the case here, we've rotated the view to be able to see the bush behind the tree, the power pole better, and then selected that, and then selected the keep out option, which will turn off the data in that view, so that you are only left with the power pole in this particular case. So keep in will keep anything that's selected in the view and turn everything else out. Keep out will only turn off the data in the view that is selected. You can use the restore and restore all option to get back to your original selection set or the original view if you want. These are tools to sort of take you back to a previous step or bring back all the data if that's what's going on. So don't feel that this keep in, keep out option is fairly definitive. The undo and redo option is also there to help you step backwards and forwards in terms of the data. Once you've selected that power pole and you've got just that power pole in this case that you want to use, you can then select the data and shift to the power pole region. So you can use the add to regions button, and you open that and select the region you want to add it to, and then select the data and click add. And that will shift that data from the region that it was in to the new region. So it is really quite that simple. Once that's done, all the data will be reappeared in this particular case, or if it hasn't, you just select restore all and that will restore all the data. So once we've cleaned up all the data and we've done all of the work that we need to get the regions created, and we're happy with what we want so that we can identify the data that we're looking at for this particular purpose, we can use the CAD toolbar in TBC. Now, you can use polygons and line strings in TBC to create the line work from your data. That's perfectly reasonable. However, this is going to be a fairly time-consuming process, which we've discussed previously. The reason for that is every line that you create, you will essentially have to determine what layer it goes on, what color it's going to be, all the specific specifications with regards to that particular line, string or polyline. All of that will have to be determined. So it can add a lot of time to this process. What I recommend doing is using that FXL that we've talked about previously as well. This is the feature code library, so that in the feature code library, you determine what you want each code to do. So whether it's going to be a string, what symbol it's going to have against it, what color it's going to have, what line style, all of that information is going to be in the FXL. So in TBC, what we're going to do in digitizing the point cloud is we're just going to create CAD points. So we're going to go to the CAD toolbar, select create CAD point. That will open up the CAD menu, and then we just give a feature code to every point that we create, and we're going to string it the same as we would do out in the field for every point that we need to create a new string for. And we'll also in TBC we can also add those command codes that will allow you to do things like create arcs and curves and things, which will make it easier down the track for digitizing. So all you need to do at the end of this is process feature codes, and all the line strings will be created. The benefit of this is all the data's on the correct layers, it's where you want it to be, it's doing what you want it to do, it's representing what you want it to represent, and also the whole process to create the data is mimicking what you would do in the field. So you would be doing essentially a digital feature survey, and this makes the whole process a lot more meaningful and familiar to surveyors than creating lines and trying to trace things around, which can just be a bit tedious and time consuming. So I recommend this process. Now, moving forward, TBC is looking at automated functionality to create line strings. I know we've talked about this previously in the past. It is coming. It won't be coming in this particular release 5.3. However, when it is available, we will be looking at that and showing you the benefits of that. However, until that happens, I really recommend using this process. It will be the fastest way of getting data out of TBC. There are also some cool macros that you can use in TBC for getting line work and data out of point clouds. One of them particularly worth noting is the points to arc macro, which is good for power lines. It's similar to the functionality that's in Trimble RealWorks, where you just pick the end of your arc, the center line, or somewhere in the center of your arc, and then the end of the arc, and in that it will just create the line string through the center of those power lines. Now, when you're doing this, the constant question is, how accurate is it? It's as accurate as the scans. It looks pretty good. You'll find that it doesn't have any issues with water, like if it was a windy day or the scans of sort of the power lines have swayed a little bit as they've been scanned. None of that issue will really be picked up in this process. So you will be able to get all your results from it. It is worth doing independent checks yourself to make sure you're happy with it. However, this is the easiest way. Other ways you can do is select the points manually and then do an approximation of line through those points. This is not necessarily a very quick way of managing that process, because you've got to select the points that you want to do that with. And it also can mean that when you're going to CAD points, it can be a bit of an issue, because the arcs, the lines that are created can be small segments, and it's not desirable. So the points to arc macro is the desirable workflow, and you can download that through the Rockpile Solutions macro set. So it is part of that grouping. Another tool that's in TBC is the extract point feature. So we're now looking at the very far right-hand side of that points toolbar that we've got, and in that is this points extract point feature function. Now, what this can do is it can allow the identification of information of a tree, a power pole, or for signs based on the point cloud. So in the screenshot on the top right here, you can see a tree has been identified, and in this, what you can do is you can give that tree a feature code. So it's been numeric in this case. It doesn't have to be numeric. If your feature code is alpha, you can use your alpha code, but 201 has the tree, the feature in the FXL for this particular case is the tree, and in that it has three attributes: a spread, a trunk, and a height attribute, which we have mapped to the parameters that are going to be captured in this process. So this process will, for a tree, will capture the spread, the height, and the trunk. We've mapped that to our feature code. So when we run this function now, when we store this point, it will know that it's a tree, and those three attribute fields will be stored against that tree. So that tree point. So what this will do is it will create a point at the bottom at ground level representing that tree. If there's a symbol associated with that tree in your FXL, it will put the symbol there. If the spread for that symbol is associated with the spread attribute, then that will all be done too. So you can actually quite quickly start to digitize your data. It means you don't have to collect this information out in the field. It works for trunks as well as spreads, so all of that is the same functionality. All we're doing is we're collecting the parameters. Now, it is, again, an algorithm. It's not always accurate. There are some things to note here where it assumes that the center of the tree is in the center of the spread, which is a very Americanized model. In Australia, we know that this is not necessarily the case, but it is a way of identifying your tree or your vegetation quite quickly. There is also an automated process where it can go through and identify all the trees in your job and string them all together to do this in one step. It is something that I wouldn't necessarily recommend running unless you have a very easy to identify set of trees and a small number. If you have a large number, you're going to have to go through and identify each individual tree to make sure that it's all there and that all the data has been collected, because again, it's an algorithm. So the more data, the more trees you're collecting at once, the more you're going to have to run through. I would use this only to really identify specific trees in your job that you want to pick up that you may not have been able to pick up in the field at the time. The other thing, that once you have attached it to a feature code, in this case, we are able to edit the parameters that have come out of this. So if the system has not picked up the tree correctly or to what you would see as satisfactory, you can modify the parameters so that and it will update in the view, so you can see what the modifications have done to better identify that tree. So you can still modify these values once it's come out, but it is recommended to put a feature code in and have this data mapped, because if you don't have a feature code mapped here or linked here, and you don't have those attributes in that feature code, this data will become lost, and you also won't be able to identify or modify those parameters if the system didn't get it right. So there's no point in running this function unless you have feature codes mapping with these attributes in this function. The other thing you can do is you can run it for power lines. For power poles. Be aware that with regards to a power pole, it is assuming the power pole is straight up and down. The point that it identifies will be the point on the ground where the center of the power pole is located. The same with the tree. The point on the ground is where the center of the trunk is located. So it's essentially saying that the top of the pole is not really of importance. It's the bottom of the pole that you're wanting and the diameter at the bottom of the pole. If the pole is changing in its diameter, we aren't capturing that necessarily. We are looking solely at the bottom of the pole here, and that is the parameters that are going to be stored. Again, if you have a feature code, it will store that information that you would want in terms of the height of the pole and the trunk. With regards to signs, it's similar to poles. The only thing it will also do for a sign is show you the orientation of the sign. So there's a little symbol that says this is the straight edge of the sign, so that you can see where that is. That's really the only difference between poles and signs in this case. The other thing, for some reason, it won't automatically identify poles and signs. It will only automatically identify trees. So poles and signs will have to be manually identified as you step through. Moving on to the tools that are available for you once you're in your point cloud environment. So These are just general tools that can be used at any stage. Be aware that for all of these tools, the ability to select points and create data from them is there. So we don't lock you out of that ability if one of these tools is being run. You can select points and you can digitize quite happily in the station view as well as a cutting plane. In the top right here, you can see the station view. This is what a general station view looks like. In this case, we've got the point cloud just as a grayscale. If you had the point cloud turned on as the true color, what you will notice in this case is that it'll be very hard to identify the point cloud because of that overlap. You'll also see in the background there is the panoramas. So behind the point cloud, the panoramas are going to be shown in the station view, so you can see that relationship. If you turn on and off data, so in this particular case, we have turned off the default layer, so you don't see that noise coming through that roundabout. That's quite happily, you can still turn on and off that data and operate it normally. The other thing is, by default, this function will just show the points that were captured at that station. You can turn on the all the points available to you from the entire project if you want. Down the bottom, there's a view filter setting that allows you to show scans from other stations. So that will turn on all of them. So the station view is quite a good view to look for data and to visualize what's going on and allow you to zoom in and out of areas, and just another way of viewing the data. Cutting planes, as I mentioned before, are very useful for a whole number of different things. There are different ways you can do cutting planes, so you can do perpendicular to east, north, elevation, parallel to the active view, 3 points, so that would be where you pick 3 points and it will create the plane based on where those 3 points are located. You can do 2 points and a normal, so that's basically you select 2 points and it'll put a normal to those 2 points. A vector plane from a planar object, as well as from a linear path. So from a linear path is an interesting one where you can draw a line, say down the center line of a road, and you can say, I want to put a cross section or a view at every 1 meter through this road, and it will create a view plane at every 1 meter down along that line that you've created, so that if you wanted to, say, digitize the cross section of a road, you can see a cutting every 1 meter. Now, this is not necessarily desirable for all applications, but it is a way of visualizing that data, so that if you wanted to pick up the curves in certain locations at a very straight section through your data of a road, then it's a good way of visualizing the data that way. Another thing cutting planes can be used for, particularly for, say, perpendicular to elevation, would be as built. So where you would go and, say, scan a car park, for example, you've got the plans, you bring the plans in as, say, a PDF or a DWG, you overlay your scan data onto that, and you could digitize your scan data and see how close the scans have matched up with your designs. With the cutting planes, we always specify thickness, so you can specify whether it's 0.01, so that would be 10 mil thick of the points, or you want to put it at, say, a meter thick. It's recommended if you are digitizing line work off a scan, though, it's worthwhile having the thickness as thin as possible, so that you can keep the line work that you are generating fairly straight. It's just the thicker the view segment here, the more variation you're going to get vertically in that line segment that's created. It's also worth noting here that thickness goes from half of the value above and half the value below. So if it was, say, 0.1, it would be 0.05 above where the cutting plane is located and 0.05 below where the cutting plane is created. So that's how it determines that. It's a question that can be asked fairly regularly. You can create as many cutting planes as you want. They can be used in other things in TBC, like creating surfaces or planar surfaces, different views. They work as just another view. You can digitize straight into the cutting plane. There's no problem there at all. Limit boxes are used to just constrain the data in terms of the view that you've got available. In the case here, we've got a limit box showing, and we've sort of constrained the data down to just a smaller section of the overall data. It doesn't delete data, it just hides the data out of the view. You can shift the limit box around, you can rotate it, you can move it using the handles, all of those things. You can also create multiple limit boxes. A good example for why you would need that would be, say, you were digitizing a building, you could have a limit box on each view for each floor, so that you could, hide the data that's up above or below, or if you had different rooms that you wanted to do, or different particular segments that you want to do in a job, having multiple limit boxes is useful, and you can save a list of them and call them as you need. When it comes to looking at CAD points, there's the Point Cloud Smart Picking tool, which when you create a CAD point, on the right, there's an easting and northing option in that Create CAD Point functionality. There's a little cloud with a sort of a blue icon next to it. This is the Point Cloud Smart Picking tool, and in here there are a couple of different options. So one of them would be like face of curb. So what this means is when you when you click to create your CAD point, it will bring up a validation, which is a tiny little scan, slice through of the data horizontally to where you've picked. And what it will show you is an option of where you can better accurately identify that particular point. So if you were picking the top of curb, you could pick the top of curb, the back of gutter, you could pick the back of gutter more accurately against where it falls in that scan data than maybe by eye. There is also ones for line markings and gutters if you want. They're a handy tool to have for certain aspects. Just be aware that if you are moving away from sort of an area where the scanner is not sort of vertically to you, you may not, this function, particularly for the face of curve, may not work as well. You may sort of see a whole heap of points that it's just showing you what the data looks like in that area, and it may not work in that case, but for 90% of cases, it's perfectly fine to use, and it's good to use this tool to better identify the exact location that you want to pick that point from. Color-coded intensity, which is in the bottom right here, is where you'll probably find yourself living in point cloud scanning functionality. It's very good at visualizing the data. As you can see here, you can quite easily see the differences between concretes, tarmac, line markings. It just highlights the data better and the different types. Now, the way that this is measured is the same as for grayscale. What happens when you do a scan is that while we send the beam out, we will also measure the intensity of the beam coming back, and that intensity will give us will be stored as a value, and we color the point according to what that intensity value is. So that is how we can identify whether it's bitumen or line marking or concrete. That intensity return is what's going to be the color in this stage. The grayscale intensity is just the black and white version of this view. Then there's also the sample region and sample by intensity tools that are in the point clouds tab. The sample by region tool allows you to drop the density of points through a certain region. It will create a new region in your project, and it will copy points at that density from the region that you've selected to the new region. So if you wanted to drop the density of your natural surface by, say, 0.5, you'd run this process, select 0.5, and it will select the points that are at 0.5 interval from each other in the normal ground level region, and it will copy them into the new region that you've created and call it whatever you call it, say for example sample, and then put the spacing at the end of it so that you will always know what spacing that new region is at. The benefit for this is that a one-to-one, for example, for surfaces, a one-to-one representation of the scan data into a surface is not necessarily desirable. There's a lot of things that can go on in scan data. You can get some noise. You can also sort of start to measure blades of grass and those sorts of things if it's close enough. That's not necessarily what you want in scans in the resulting surface, because while it may appear to be more accurate, it's not. It's better to simplify the data. The other thing that you're going to see here is that it will drop the number of triangles that it creates, and that is going to be a key for handling that data further on. It is worth noting that TBC does have a limit, and you can change the limit for the number of points that it uses to create a surface. So be aware that in the preferences in TBC, there is an option that specifies how many points are going to be used to create that surface. It's a maximum number of points. The reason why that is there is that it is to limit the amount of memory and how big a resulting surface will be. So if your maximum is say 5 million points and you've selected 10 million points, it will automatically interpolate the surface and pick 5 million points to best represent that surface rather than the whole 10 million anyway. But dropping the density allows you to have control over what points you're using, how many points there are, and also produce better surfaces that are going to be more meaningful moving forward. Sample by intensity is using the parameters in essentially that return that we were measuring, that we're using in the color-coded intensity. You can select a range within that sample by intensity tool that will say, I just want to see the points that have this that are within this intensity band, and you can select those points. Now, this can be used for, say, identifying bitumen, for example, or that sort of thing, and putting those onto a new layer if you want. Just be aware it's going to be everything within that intensity band. So if there was, so in the case of the screenshot here on the right, you might find that some of the power lines and some of the tree get shifted in there as well as the road. But it can be a good way of identifying certain returns which you might be looking for, and then you would just essentially tidy up those layers anyway. Once you've gone through this whole process, so we've imported the scans, we've georeferenced them if we need them, we've colorized the scan according to true color so that we can use that later on. We've digitized the scan using the CAD tools. We've processed the points to create the line work, and we've done the trees and the power poles. We're now ready to create surfaces and contours. The reason why I would do all of that work before this point is because any line work that you have created and have selected when you create the surface will be used as a break line. So if you want those nice crisp lines that you would like to see, or that that better represent the surface using break lines, then you'd need to have gone through all those steps to get to this point. On the right here, you can see the part of the surface that has been used to create, that has had line work created in the break lines against that surface, and has produced those crisp curving edges that you would expect. Whereas on the screenshot down the bottom right, we haven't got that, and you can see it just sort of looks a bit of a fuzzy mess. Now, that's just because the surface on the bottom right is just interpreting the data as it is, whereas in the top right, you can see that it is those crisp lines because we have those break lines in there. Again, whether the line work is included in the surface or not is predominantly determined on whether it's selected in the surface generation tool or not. But secondary to that, if the FXL has been used to process that line and the FXL says don't include this point or line in the surface, then that won't be included. So in that case, if you've created line work between the bottoms of your pits to demonstrate where the pipes are going through, you don't want that included in your surface. Even if you do include it in this step to generate your surface, it won't be handled or used as a break line at all, because the FXL has said, you don't want that included in the surface. So you do have that flexibility to control that better. And that again is why I would recommend making sure that you can run through the FXL, creating CAD points function so that all the points do exactly what you want and the lines do exactly what you want it to do. In TBC, we've talked about surfaces and contours in the topo generation group session that we did earlier, but you can do editing of long triangles. There's a parameter in TBC that allows you to edit the triangles on the edge. We can also specify in TBC not to create triangles longer than a certain defined length. So it's worth making sure that that is correct. That's in the properties, and that can be stored against a template. It is recommended when you create surfaces in TBC to select the data that you just want to select, particularly when dealing with point clouds. You don't necessarily want to create a surface that goes onto all of your data, because it can get messy the further you are away from the prime area of your scan. So I would just select the area that is the prime area that you are looking at for your scan to create your surface, so that your surface is going to be optimal. Once you've created the surface, just use the add and remove function, and don't make continuous edits to create new surfaces, because you're just going to be juggling all these new surfaces that if you make edits. All the surfaces in TBC are dynamic, like most things in TBC. It's dynamic, tied to the edits and changes that you make, and they'll be updated as you make those changes. So just keep one prime surface with relation to what you're looking at, and then make edits against that. remember, you can add and remove elements, so you can add the footprint of a building in to remove a hole, for example, or create a hole in TBC into a surface in TBC. So all of that functionality can be there and utilized quite easily. Once you've done that, it's worth creating the contours. So the first step would be to create the surface, and then once you're happy with your surface, then I would create my contours as pretty much the final step. There are a whole heap of properties with regards to creating contours that we have sort of talked about previously. One of them particularly is that you can create major and minor contours. Based on the interval, you can color the major contours differently to the minor ones. They are all put on the same layer. You can't specify a different layer for your major and minor contours at this stage. But it is worth noting that you can also make sure that you put 0 as your text for your labels, for the distance between them, and that will make sure that labels aren't put on. You can come back and put labels later using some of the other function in TBC, such as create labels by line, which will put a label at every point that the line crosses over a contour, which can make a tidier output at the end. But remember to, if you need to make an edit in your contours, you make the edit in the surface, then regenerate your contours, and that will work. So once you've done that step, you're pretty much ready to go out. And there are all sorts of things that you can do in TBC to help you take your data out somewhere else. So in TBC, you could do all of your drafting and work in TBC. So we have looked at the drafting functionality in TBC previously in one of the other sessions. We'll run it again this week if you would like to know more about it. But you can do all of your line work, push that out to drafting plans, and then plot them out in TBC. You could export the line work out to CAD. I would recommend that you don't export points out to, say, AutoCAD in a DWG file. By that I mean scan points. Scan points are very dense, and the DWG and DXF format is not is not designed to handle large numbers of points in large data sets. So just be aware it's best to keep your line work to any export formats other than a point cloud format itself. You can export your point clouds to a point cloud format. So point / las. TBC, we do handle all major formats and all of that sort of thing. So we can go out to pretty much all industry standards. The other option is to go to Clarity. So in the top right here, you can see an image of a point cloud in for a better term, the cloud. This is Clarity. What we can do is we can upload a point cloud and line work and also surfaces to Trimble Clarity, and what that will allow you to do is host that particular project and share that with customers. You can share them a link. That link can be based on a password at a certain time if you want it to, or they can just have it and they can just log in, and you can also have a login specification if you want to as well, but they can just follow the link, go online, see the point cloud in a web browser. You can even view it on the phone. You can do slice throughs of the data, you can do measurements, you can annotate, all of that can be done. So you can share a project with a customer means that they don't need to have a full 3D or a scanning package or something like that available to them. They can just rely on looking at it in the cloud and rotate it around. It's handled just like Google Earth. You can have multiple projects. There is a pricing model associated with multiple versions of this, multiple projects being stored in Clarity. So if you want more information on Clarity, please reach out to us and we'll be happy to help you with that. Again, with Clarity too, you can upload data so that if it goes from TBC into Clarity, you can see the station locations and panoramas in Clarity, so that flexibility is now there. The other thing out of TBC is you can just get your panoramas straight out if you want, as well as your ortho photos, and share them in the package that you want. And there's multiple other things that you can do in TBC. If you created surfaces, you could create 3D PDFs. There's all sorts of other export options that you can use. So the process. After all of that, the process that we would recommend is to import the data, register the scans, adjust the traverse if needed for an SX10, create the panoramas and colorize the scans so that you've got that colorized if you need to. You can use that for your digitizing. Create and tidy the regions so that the data's there. Then generate the CAD points and line work so that you can then have your 2D aspect for that if you want to do that. Extract the point cloud features, so that's where you're using the trees and the poles to export the line work automatically. Create a surface from the line work using, or from the points using the line work so that it's got those sharp edges and all of that. Then you create your contours after you've tidied up everything, and then you publish. And that's essentially the workflow that you would run to get the data out of through TBC and out. Now, it does sound like there's a lot here, but it is quite a straightforward workflow, and it is using a lot of things that should be already familiar to users, or it's a good way of actually getting into TBC and becoming familiar with a whole different slew of aspects in TBC. Also remember, if you want to take the data out at any point, we can take it out. So don't feel you need to do the whole process in TBC. I would always recommend doing as much as you can and much as you feel comfortable in using in TBC at this stage, and then going out to an external package, and then looking when you feel a bit more comfortable at pushing that out until you can you just essentially run the whole step in TBC. So with that, if anyone's got any questions, please let me know. That's my email address. I am going to run through a demonstration right now. So the first thing, if you want to ask any questions, just pop them in the chat. What I am going to do is I'm just going to load up a project that I've got here. It is the large data set that I was talking about. So let me just get my TBC. Right, I'm going to share the desktop. And right, so hopefully everyone can see my desktop now. I'm going to double click on my Quarry project here. Now, this project is a project that has 3 billion points in it. The reason why this project was done was we had access to a site. There we go. We had access to a site that allowed us to do a whole heap of scans. It's not just one particular scan type. There is UAV data in here, there's SX10 data in here, there's also TX8 data in here. But from scratch, using my laptop, this is a demonstration of how long it takes to load in 3 billion points. So it's not a small project by any means. And here's the project here. I've actually loaded it twice. So this is the project here. Hopefully you can all see that. As you can see, if I rotate around, there's quite a lot of data in this particular project. If I go to my point clouds tab up here, I can change the scan color. So these are all the different scans that we've done. The blue is a UAV data. The red here is an SX10 data. The SX10 data scan was a 2-hour scan, so it was quite a detailed scan. There were multiple passes, but it was to get that higher detail, and it was from one setup location. So this is taking benefit of that large distance that an SX10 scanner can actually obtain. When you're looking at this, I can rotate around quite easily. You'll notice that it turns off points as I zoom in and rotate around. This is how TBC handles those large data sets. If I go to my true color, you can really start to get an idea of what the appearance of this particular project was like. Even underneath here, down the bottom, you can see that there was scanning that was done underground that this has all been tied to. Now, for example, if I show you now, if I go to properties, there are two main groupings here. Never classified is my UAV data. There was 16 million points in that. But if we look at the rest of the data set, there's 2.919 billion points in here. So it is a bit shy of 3 billion, but you know, it's just a bit of loose change really in the scheme of things. So I would be quite confident in being able to load in a whole heap more points into this project if I wanted to. Again, rotate, scan, all of my functionality is available to me. So, and this is not a powerful laptop either. It's a good laptop, don't get me wrong, but it's not like high-end optimal laptop, and it's not a processing computer. So don't feel that I'm trying to, throw any tricks at you either in this process. So that's just to reassure anyone that's wondering how many points that we can handle in TBC and what it's like to rotate view. It is manageable. Again, you know, if I can increase the size of the points, all of that can be done. So I won't close that. The other one I wanted to do was to run through, if I load this one, we're going to start from scratch, and I'm just going to do a quick run through. If anyone wants, I am recording this, so feel free, you can come back and view this later if you need to go on to something, but we are going to do a quick run through of the data in TBC, of that roundabout project, just so you can see some of the things and the workflows involved with it. Please feel free to ask questions in the chat as we go through this, and I will come to them at the end. So here's our TBC. What I'm going to do to start with in TBC, this is the blank startup page. I'm going to go to File, and I'm going to create a new project. So we're going to use the GDA 94 template because I know that's what the project's in, and we've just loaded our template. In our template here, I've got my code library on the left-hand side. You can see this is my feature code library. We'll be using that later. There is also going to be a projection set. So if I come up the top here and we look at our coordinate systems, our projection has been defined already in TBC. So this has already been stored in a template. All this information has already been loaded. What I'm going to do now is I'm going to go to my desktop and I'm going to pull in my job file. So this particular project is about 30 million points. It was done of a roundabout, and as I mentioned previously, what they've done is they didn't want to close off the road. They didn't have traffic management come into managing this particular job, and they've abided by safety concerns by setting up scanners off the edge of the road so that it's, you know, the workers are safe, and you're really just worrying about these jobs. Now, each scan is about 45 minutes. It's 4 rotations so that we are getting sufficient coverage. The reason why we're getting sufficient coverage is because if a vehicle passes through in the first scan, we're going to get that what's called shadowing effect that you get in scanning data, where you can't see behind what the scanner is seeing at that particular point. So the idea of doing multiple passes is if you do a second or a third or a fourth scan, one of those scans will get the points behind it and you'll get the data that you're looking for. This will still be faster than doing this manually out in the field, and it will also be cheaper than doing it out in the field because you're not relying on multiple parties being out there at the same time, and you're also not annoying the general public necessarily because you're able to just set up, scan, do your job, and there's no interference between each group. We're finding that a lot of people are starting to use scan data to identify roads and this sort of thing for these reasons that we've sort of talked about here. So once the data's come in, this is 5 scans, and I'll show you that in a minute, but it's been quite quick to come in. Remember, I have turned off that point cloud colorization step. You can turn that off in the options. It's up here. If I go, I'll first view the properties. So when you bring the data in, there's some warnings. It's just saying that one of the resections might be wrong. In this particular case, we just have a tolerance that's not been set, and we're quite happy with it. In the options, what are the options down here in point clouds? Turn off colorization. This is the option that you would turn off to bypass that step. This is also the point that you would use for the maximum number of points in the surface definition and some of your other settings for point clouds, including the memory that you're going to be using. In terms of your memory in TBC, we only will ever use a maximum of half of the amount that's available on your machine. So this machine has 16 gigs of RAM. We're going to only be able to use 7.9 in this particular case because it leaves the rest for the system and the rest of the functionality. So just be aware that if you have a more powerful machine, this generally is set to 2. So you may want to come into the point cloud tab on the options and change this. Just while I'm here, remember that the use icons for quick access, use large icons for quick access toolbar is another thing that I would recommend turning on. That just makes the bigger icons along the top of the screen. So here's our project here. As you can see, it's an SX10 job. So we have our Travis, our total station lines for the Travis in here and our scan stations. This is our plan view. I can go into the View Filter Manager, look at raw data, and I can turn off Total Station, and that'll turn off that green line work, so I'm just left with the scans. You can see little folder icons over each of these setup points. These show that there is some form of data associated with it. In this case, it may be the image of the total station and things like that. It just represents that there's some additional data available at those points which you can utilize later. First thing I would do here would be also turn it into 3D view just to represent the data in a little bit better. So if I rotate around, you can see here we've got our roundabout, and this is the vehicle noise that I was talking about previously. So this is our first hurdle in handling this data. You can also see here through here that maybe that there is some noise, and that's where, sorry, some shadowing, and that's where we haven't been able to collect the data even though we have done multiple passes. There's some shadowing still occurring, but it's very minimal in comparison. So if I go to the point clouds tab, the first thing we can do is we can turn on the scan color. So the scan color looks at the point, it will colorize the point depending on what scan it was taken from. This allows you to identify where that data was being collected from. It also allows people that weren't out in the field at the time or are unfamiliar with that location to see what went on in that project and what data was collected from where. So it can be a good tool to see what is going on in the project. Region color. So we only have one region at the moment. We haven't done any classification of regions. If I select the point cloud, as I mentioned before, it will select all the points because it's just handled as one single region entity. Grayscale intensity is that default that comes in. Color coded intensity is when we add a color overlay to that grayscale intensity, so you can see that different color intensity through your project. You can see here that surfaces like concrete against bitumen and even the line markings are being highlighted, so you can really start to identify different aspects, and generally they're the aspects that you're looking for the edges of, so it's a very good way of looking at the data. True color, we haven't quite done any true color representation yet, and then we have color by elevation, which for most cases it's a bit of a Technicolor Dreamcoat, but you may find it useful. You can reset the height that this averages out to so that you can shift that up and down to be a more meaningful height that you are getting. You can also specify the bands as you see fit. Over here you can see small, medium and large. So small is 1 pixel per point that was taken. Large is 4 pixels per point. So you can see it just enlarges the data and it can be a bit easier to see. There are other options such as ambient shading and normal shading, which if I turn on my color coded intensity, you can start to see the effect of that. It just gives you a bit of a shading model against the scan data. You can turn on orthographic or perspective view. So when you're in perspective, it does slow down the machine a fair bit because of the processing that it requires to calculate the location of the points. However, it can, if I go this back to small, you can start to see that sort of distance effect that you would see from a perspective. It's easier to pretty much work in orthographic though, it just helps. Z up, axis up, means that it will always keep the Z axis up. If I turn that off, you can quite easily start to really flip the model, and it starts to become a bit hard, but it can be used to see underneath things or around things that you may not be able to traditionally see. So the first thing that I would do would be to process our panoramas. So process the panoramas. What we're going to do is there are two options here. The first one is to balance the exposure for all the images. If you can either select each individual image, or you can select the top button here, the icon at the top, and it will select all of them in that field. The other one is we're going to blend the edges of the images so they're less noticeable, and then we go process. Now this is not a wasted step. This is to be used for any data that you're going to export anyway from that image data, so it's worthwhile running this anyway, even if you weren't to run it for your colorization. The only reason most cases you won't see a difference in the colorization step by running this process. It's just going to be sort of a minimal difference, but there can be a change, and it's worth running this step anyway to make sure that it's done and to just improve your images, even if it is just going to be fairly minimal. And as you can see, it's fairly quick, so it hasn't taken that long. Once that process is done, you close that. And then I can go to colorize my scans. So this is over here in the rendering section. Again, I can select each one I want to colorize individually, or I select the top and go process. Now, as this goes through, this process will take a little bit longer, but it's still manageable within the demonstration time. It will just go through each of the panoramas that we've just created, and it overlays the image, the pixel on the image, and determines the color that the pixel of the scan is against the pixel of the image, and that's how we get the colorization. This step, because you can get a little bit of a shift between the image, particularly with the SX10, if you're using not the central camera but one of the other cameras that's a little bit offset, you can get a little bit of a shift, which can make the trees look a little bit like it's been snowing. This is just because there's just a slight shift between the pixel and the image. Now, if you want to correct for this, it's called parallax. If you want to correct the parallax difference, you can use the central camera in the SX10, for example. This will address that issue. Just be aware that when you do that, it will be a bit slower out in the field. However, it will create a better set of images for your scans, and you will remove that essentially that shift. It's not a huge deal. It's just something to be aware of, and it's really only going to be on things like trees where the tree may have shifted slightly in the wind and the image was taken at a different time, or there's just that very fine edge that is being picked up in a scan that is just going to miss the edge of the image. This is fairly common in any scanner or any system on the market, so it's nothing unique to how TBC handles it. It's just something to be aware of. Again, you can see here the number of points. So on the right hand side next to colorized scans, you can see the number of points that are being colorized in this process. If there's any questions, not at the moment. So this step, as it runs through, it can update in the view. So if I had True Color turned on, you would see every time the slider is shifting to a new section, which seems to be in large chunks, that will be when it's colorizing a chunk of your point cloud. There's no real benefit. So this is that point where you'd go away, have a cup of coffee, and just wait for this process to happen. It's quite quick, but this is also why you would bypass this step on importing the data, because you can just get straight into it if you want to do that. It's almost done. The other thing to note here is that there were 2 scans done at each station setup, so it was not just the full dome scan. There was some window scans done at each setup, so that's why there's 2 colorizable scans in each of these particular setup stations. So now that we've done that, we have our true color image and we can see our particular project. So with that run, I would then go to classify regions. So I'll just close all of this down. If I go to classify regions, what you can see here is we're going to select the data. So that would be the data that was selected. So you just select here and you select your point cloud region. There's our data selected. What we've then specified is to create 1 new region per class. So what this means is if you untick that, it's going to create its own region for each individual group. So it would create, if it found all the points associated with building 1, that would become a new region. And then building 2 would be building 2 and building 3 and building 4 and so on. When you create 1 region per region class, it just creates a building region and all the points associated with that will go onto that 1 region. So it is worth making sure you run that. Then you have the classes to extract. So you have buildings, ground, high vegetation, power poles and signs, and power lines. If I click extract now, this will run through that process on this data. So you can choose not to run, say, buildings or high vegetation. You could just get ground, power poles and signs and power lines, and that's completely fine. There's another option over here on the point clouds toolbar called extract ground. And what that will do is that will just extract the ground. So the benefit here is this is more for, say, UAV data where you just want the ground. This will just go through and extract the ground points from that project so that you only need to worry about that. Another thing to remember here is that with buildings, you need that vertical component. So if you are taking top-down images in UAV data and there's no sort of side-on image that you're capturing in UAV data, you may not capture a building in this process because it will only have the roof line. There's no vertical to determine the shift from the ground to that roof. And that's what the algorithm is looking for in this case. In those cases, it does just put the roofs as a floating element on the default layer. Remember here, we are still creating a default layer, which is where we put any unclassified points. So that process is now run. We've gone through the 16 million point or the 30 million points in this particular project, and we now have our regions that it's come out with. So what you can see here is green is your vegetation, brown is the road, and then blue is the buildings, and yellow are the power lines, and everything else is on the default region. The other thing you'll notice over here on the left, if I turn this, hide these all, you can see our regions. You can turn on and off scans as well. So if I want to turn all the scans off, I can do that. I can also turn off independent scans. So the scans are still held independently to the regions. It's just, we have another option for viewing data. So if I turn it all off and I look at just high vegetation, for example, here's our high vegetation result in this particular case. So what you can see is this situation here in the middle, where we've picked up the traffic and it's identified as being traffic, as being high vegetation, because essentially it does look like a bush to an algorithm. Now remember, the algorithms are looking at it mathematically, so we do need to take that into consideration. It's quite easy to change. So what I've done is down the bottom here, there's the different options. There's polygon select and rectangular select. I'm using the polygon select and I've started to select some of the data. So just be aware, now I'm selecting it, I'm trying to rotate the view and the view has become locked. This is perfectly normal in TBC. When you're in the middle of a polygon select option, it won't let you rotate the view. You're locked. I can still zoom in and out. I just can't rotate the view around. So if I go through and I just finish selecting this data, here's my data here. We don't care about the setup locations. That's something that TBC will do too, is in this case with the SX10, we'll put a little SX10 setup station to show you where each of those stations were. It doesn't care about any points, it's just looking at the point cloud at this case. And then what we're going to do is we're going to add to region, and then I'm going to add these points to the default region. So when my system catches up, here we go. I'm going to go to default and go to add, and those points have now been shifted from the region that I've got, the high vegetation region, to that default region. So if I turn all my points back on, here we go here. Now, why would you want to do that? Because if I now turn off my default region, so if I come over here and I turn off the default region, you can quite quickly be left with just an underlying scan. It's, you know, this is very easy to just get this as your base level. You can see here that shadowing from anything that's slightly missed from being picked up from the scanner that we're talking about. However, overall, you can see quite well the effect that this is having. You can get to all the points that you would want to pick up in this particular survey, and you would then just go through. Now, for example, at this point, I could just select my ground here, and I can go, all right, I want to create a surface. Now, I can go through and create a surface using this. This is my area of interest, for example. I can go to surfaces, create a surface. It gives me my options. Let's call it OG for original ground, not original gangster. Click OK, and it goes through and it will create a triangulation of my project on just the area that I have selected. So TBC will only handle the area that you have selected. It's gone through, and if I now closes that, if I now turn off my ground, here's my surface. Now you can see here that there's bubbles and points. Remember too, I had those setup points that were located, that were selected in my surface generation. So this is a case where they will be included, because it is a specific height and seen as a point, so we are seeing spikes in that data. So here's our surface. Now, again, this is why I would recommend not running the surface until you've created that line work. You can see sort of particularly out through here that it starts to become a bit fuzzy. Same thing down through here. So it is worth doing this at a later stage, but what I'm trying to represent is the ease of creating points and surfaces once the data is in TBC. If you then wanted to, say, scan to CAD, if I wanted to create CAD points at every, say, 10 meters through this intersection so that that data could be going out, let's say 10 meter spacing, and we go apply, and where I've got to select my scan. So if I go ground, and then we're saying, there's my scan, go apply. That's going to go through my scan, not my surface, and put CAD points on the 0 layer. So if I now turn my ground off and my surface off, there's my scan, my CAD points every 10 meters. From there, you can then look at, say, adding a point label to that. So if I want to select the points to label, I can do that. So that one, sorry, that one there. We'll select this here, and we go options, select similar. That one there, go OK. That's selected all my points, and then go add. Now I've got text against that. If I go to my plan view, here's my text. Now in text styles, you could then go and change that size. So let's say I want to change the height of that to something a bit more meaningful. Let's call it 1. That's dynamically updated that text. Now if I wanted to change the points, I can go to my point style, remove, I don't want the text element, so let's remove that. And let's say we want to put that at 45 degrees, go OK. And when you've done that, there's pretty much a quick way of getting some labels out at spot heights through your project. So looking back at, if I turn my layers off now, if I look back at my scan data here, I'm going to turn my surface off and turn on the ground. If we wanted to do that same process, however, we run it at, if I go to my point clouds, sample by region. So if I want to drop the density of that region, if we run through that process again, except this time I select my area here, we're going to drop it down to 0.5, store. What that's going to do is it's going to copy all the points at a 0.5 spacing. There are now this number of points. It may be a bit hard to see. If I increase the point size, there's my new point cloud there. You could then use that to create a surface. So if I go to surfaces, create surface, and we go NG for new ground and go OK, we're going to create a quicker surface. If I turn these points off and we go back to the 3D view, we're still getting a good surface. It's a lot quicker and a lot easier to represent and manage the points at this location. So that's looking at basic surface creation straight off the bat. Another thing that we can do is in that high vegetation layer, we've got things like the power line. So when I was looking at that power pole earlier, in the example, here's that power pole here. And to show you how to shift it from one layer to another, I'm going to use the polygon select tool again. I'm going to select that data. I'm going to close that just to get me a bit more space. And then what we're going to use is we're going to use the keep in, keep out tools along the top here. So if I want to keep it in, if I select keep in, all I can see is this particular data here. So then if I want to get rid of that particular data, I can go keep out. And then I can run that again. I could select the power pole and keep in as well at that point, doesn't really matter. There's our power pole, go to add to region. We're going to shift that onto the power poles and signs and go add. And now we've shifted that data from the vegetation layer onto the power poles and signs layer over here. There it is there. So it's quite easy to use that keep in, keep out. Once you've finished, you can click restore all if it hasn't seen all the points come back. Otherwise, just turn on and off your layers in the default, in the view filter manager. We were talking before also about macros. I have, if we just turn on the power lines, in the macros over here, there is a points to arc. It's over here. I found it this time. We're going to select it. It comes up with a name. We'll call it power line. We're going to select coordinate 1 over in the top left here. Then I'm going to pick just an arbitrary point in the middle, not too concerned. I'm going to pick a point over on the right, and that's now put the data on the 0 layer. So if I turn on my layers and turn on my 0 layer, we still have that text underneath, but here's our power line and the sag through that power line. Remember, down through here, it's worth noting that it was a windy day and there's a bit of variation in the scan. However, overall, we've identified a pretty good location for that line to be fitting through that power line. You would just simply do that for all the power lines that you need to do. It's quite a straightforward and easy process to handle. So what else have we got? Another one that we can do here is we'll turn on high vegetation. Turn these off, high vegetation, and we're going to look at the in the point clouds tab, there's the extract point feature option. So this is that functionality that I was talking about, where we're going to use an algorithm to identify information with regards to points that are coming out of the system. So we're going to select tree. So there's also tree, pole and sign, tree, manual, automatic. We're going to do manual. We're going to pick a point on the trunk. So you just go through and you just identify a point on the trunk. There's our point. Not quite. Let's try that again. There we are. There's a, there. Pick a point in the trunk. There we go. So I know my feature code is 201, so that's fair enough. And I've already had these mapped. So I've manually gone through. These are attributes against the 201. So in numeric, if I go down to vegetation and 201. Now, a question that I have been asked, it does not need to be numeric. These can be alpha, but I can expand the attributes out to height, spread, and trunk. So these are numeric attributes. Here are these here. So really, we're just going to populate the information that we collect here into these attributes against this point. So if I then go extract tree attributes, what this is going to do is it's going to identify the center of that tree, the trunk on the ground, as well as the spread and the height. And these parameters are here. Now, because I've got these mapped, I could say this is 15 meters, for example, but it's not. So what is it, 9.5? You can make those edits on the fly, and when you're happy with that, you just go add. Now, I haven't got my symbols turned on, but if I turn my layers on, you can see that that tree there is now representing on the ground the symbol based on the spread of the tree of the parameter that we've got. So that's all been scaled and done based on the parameters that we have, and this has all been done and managed through our FXL. If I then turn on, say, power poles, I could change this functionality, sorry, not power lines, power poles. I can change this functionality so that we are looking at power poles. So if I just being a bit slow at the moment. Let's open that. So if I turn that off, we're just going to look at the power poles, and we're going to try it again with the power poles. So in the drop down list here, what I'm going to do is I'm going to deselect tree, and I'm going to select pole instead. And I know that it's 712 is my power pole feature. If I do the same thing here and I select a point on the pole, here it is here, extract pole attribute, system quickly goes through and works out all the points associated with that particular pole, and then it will determine the parameters. So there's my pole and specification and the ground location and the information here. Now remember, any point that's created from this information, if I then go to that point and I see the attributes, it will show me the attributes. So if I went to add now, that's added a point, and that should now, if I close this out, if I select that point, as you can see here, I haven't got a symbol associated with it, but if I go to the properties, that information for that particular there is the height and the width that have been stored against that, which now can be exported out. If I now look here, we've got our CAD tools. That would be the other one that we can do. So if I look at my CAD tools, I can create a point, and we would just put in a feature code for 40301 in this case. I'm just going to use the easting, and then you can just go through and click enter, and you can just basically digitize it that way. Now if I click 40302, so I'm going to start a new string, and I do this, except this time I open my point clicking tool. So on the right next to the CAD, you click smart picking. This will open up the smart picking tool. I can drop down, go face a curb. Now if I select a point in here, I can see what the curb looks like, and I can pick where I want that point to fully locate. Let's say we want it down here, for example. I'm just being a bit rough. Going to go add. We'll select a new one. We'll go here. Validate and go add. And we'll select another one over here. And then go add. So there are some points. The idea being now that once we've done this to the whole project, if you then go to survey, process feature codes, what you'll notice is this is my imported job file. So it's the data that I've imported from the data coming in from the field. If I select keyed in block, this is data that we've created in TBC. Go to process sources. I've now created my line work quite quickly and easily against that in TBC. You would just go through and change your feature code and your stringing and handle that as you would normally, and just go through your entire project and digitize it that way. So that would be just building up the data, looking at that process. So in all of this, you'd be ending up with something that would be quite manageable and easy, and you just deal with the data as you see fit, and you're only looking at specific data types in different areas. With that, once you're finished, you can export out. So you would export to point clouds. The point cloud data would go into one of these particular formats. For CAD, you would select a CAD format. If you wanted to go to Clarity, you could go to point clouds and select publish to Clarity. So that will take you out to Clarity. Going to Clarity from TBC will include line work and points. They will be exported as a KML. You can export a surface. However, if you export a surface, it needs to be done manually, and you would export it as a SketchUp file and then position it manually in your Clarity project. If I load Clarity from my particular project here, so this is TBC, this is Clarity opening. Hopefully it works with the stress on the internet with sharing everything, but what it will do is it essentially will open up a globe. So it's like when you open up Google Earth. Down the bottom here, what you see is you see a drawer of all the projects that you have loaded in Clarity at a particular time. You see also a toolbar over here where you have the options to import data, add data, and data manage. There's also tools within that. Clarity is a sharing service which Trimble doesn't necessarily store the data. You can store the data in your own service, such as Dropbox, Google Drive, those sorts of locations, and then share the data, link the data to Clarity. So Trimble is not hosting or storing the data. It can if you want, but it doesn't if you use your own service or you have data security concerns. You can host your own service on your own servers. In that case, there is those limited listed services that we've got currently, but we are looking at new methods, or Trimble is, as they go forward. But the idea here is that you still have control of your data. Trimble doesn't own it. Then in the project down the bottom here, I can select a particular project that I'm looking at. This is the project here. As you can see, the point cloud loads up quite quickly. I've imported a surface as a SketchUp model and positioned that independently, but you can see my line work and my points, as well as the point cloud itself. So it is quite quick, it's quite usable, it's easy to manage. In the case of other projects, you can zoom in and zoom out. You can see multiple projects here. If I go to the project that we looked at, this is the office in Melbourne. It's position. So underneath it's the Open Street View, and you can see here we've done internal and external scans. I've done a slice through of this particular project. Again, you can rotate it around, you can zoom in and out, I can change the pixel size. It will be somewhat dependent on your internet connection. As you can see, it buffers the data in chunks. However, this can be done in projects. You can share it on mobile, you can view it on mobile phones out in the field, you can do all of that sort of thing as well. So it is worth looking at Trimble Clarity. It's a good service, and if you want more information, please contact us. With that, I